This video will cover the necessary functions you need to complete problem set 6. I just want to say congratulations for getting through the semester. I think many of you were probably a bit anxious and nervous about using R and using RStudio because some of you may not have ever used software like this, but I really want to let you know that if you were able to kind of come to use it and become comfortable with it, that you actually probably can learn almost any programming language if you set your mind to it. Luckily, RStudio has some similarities with a lot of other really good programming languages, including Python. But I really think that it can the knowledge that you gained, hopefully this semester, can be extended to other programming if you were to want to do it. And I'm hoping that I helped make this all a lot less intimidating for you. So please reach out if you have any further questions about what you could potentially do with RStudio beyond this class. And what you could do with this type of statistical software. It's very important today to understand, I think, what statistics is and how it works, because it really has a huge impact on all of our lives, from YouTube to Facebook to Google. All of their algorithms use these statistical methods that I think really impact our lives greatly. But anyways, I will stop there and try to get done with the last lesson. So now we will go ahead and import the data as we usually do with this read.csv function. And then inside we will put the name of our CSV file, which is in the exact same folder that our R code is currently in. Now, if it was in a different folder, we would just add that folder name as we would here, and then a slash followed by the name. But it's in the same folder, so we can just go ahead and download as we usually do. So now you can see that the DF has been uploaded, and we can take a good look at that data frame by just using the head function, which will show the first couple rows and the columns. And after that, we will install this dplyr package. And then I've already done that, so I can just go ahead and use the library function followed by the name of the library, which is dplyr. So I run that. It looks like it worked. You may see a red warning sign, but usually it will work. And so now we can move on to the first problem. Before we get to the regression, we need to create a new variable, which is the percentage of total household expenditures on food. And so that can be done in a number of ways. The first way is in dplyr using the mutate function. That mutate function, all it does is create a new column, which is what we want to do. And so we type in the name of our data frame and then use the pipe operator and then type mutate. And then we put in the new column name, which is right here. Again, this can be named whatever you want. It can be a new column. And then we set it equal to whatever manipulation that we want to do with the existing data that we have. So this food and total expenditures, as you see, if you take a look at our data set, are actually just already existing columns. So it will be food divided by total expenditures. And so when we run this, you will see that it spits out the results in our console below. And if you scroll all the way up, you'll notice that this new column was created. But if we want to save it, what we actually want to do is exactly what I show in this example here. You say df equals to that exact code that we did, and then it will save that new column. So there's this blue down here. It looks like it worked though. And what you'll notice is that it did work when we go check the data. There's a new column there called per food. So the other way to do it is just to use this little dollar sign followed by the new name of the column that you want to do, and then equals to the food column of the DF. So when we're using this method, you have to specify the data frame. So that's what I'm doing. And so we're dividing that food divided by the total expenditures. So if you do this, it will actually just overwrite this here that we did in the mutate column, but it's the exact same output. So in the end, it's the same. You can do either. And then if you wanted to not look at it through the df, you could just use the head function and see that we have a new column there. So now we can go ahead and do a basic regression. I'm not going to do the one from the problem set because I think you'll be able to do it yourself now that we have created that data and I showed you how to create that data. So the basic regression, I think I showed you in the last problem set very briefly, but you're going to use this LM function. So let's just specify that here. You're going to use the LM function. Let's put that right here. And this example I'm going to use from the mtcars dataset that we've used many times. So we are going to regress miles per gallon on weight of a vehicle. And actually, it's not mtcars. Let's go like this. And it should work. So what we just did there is we specified in this data set, so if you look at the mtcars, we have two columns. One is weight and the other one is miles per gallon. And so with the LM function, we are just actually only typing the names of the columns. So the miles per gallon will be regressed on weight. And then we specify where that data is coming from, and that data frame is the mtcars data frame that I just showed you. So when you run that, then it will spit out this output, which gives you the coefficients of the regression. And so I'll just show you what you could do if we were using data from the data frame that we imported. So let's just say food and total expenditures. So we could do that by doing to food, and then what's the name of that column? Total exp. And then the data, this time it's not mtcars, it will be from our data frame. And we run that, and then you will see that it worked, and this is the output. So this example is going to be similar to what you need for your problem set. And so after we have run that, we might want to inspect some more information. So what we often do is actually save this as an object, kind of like what we've done for our data frames before. We do the same exact code that we had up here, except this time we set it equals to whatever name that we want to put it at. I mean, you can write my regression, whatever it is that you want to write. And then you run it, and then you'll notice that there's now an output. And so now what that allows us to do is we can take this summary function of that saved regression. And so if we run this summary function, let's just be clear about what we're doing here, then you will notice that we now have a little bit more information than before. What we ran in this using the LM function was really basic, right? It only gave us this output. But when you put this summary function around it, you'll get a ton more information on the residuals, coefficients, R, I think you can get R squared. Yep, R squared, p-value, and a lot of other information. So that allows us to answer, I think, question 1A and 1B. You can also use this confidence interval function by just writing conf int, and then inside is that same regression output that we saved, and then that will give us the confidence interval. Now we will move on to graphing the regression lines. I think I briefly again showed this in the last problem set, but here we go again. We are just going to first do a scatter plot, and I think you should have an idea about how to do this at this point, but we put in our first data, where I'm again just using this empty cars example. I'm going to be using the weight of cars and the miles per gallon and selecting those columns by this little $sign, and then I'm going to graph it. And what you'll notice is that there seems to actually be some negative relationship between weight and miles per gallon, which makes sense because the heavier the car, the less miles per gallon you're probably going to get. And what we can do actually to that existing plot is to add this AB line. And so we are going to be adding the AB line from the regression output, that data that we have saved. All we have to do is put that in the AB line and then run both of those lines of code together. And what you'll notice is that this is our regression line. So if we actually look back to that summary, what you'll notice is that the intercept is 37 and the weight is -5. So these are the coefficients for the regression. And if you look over in the data, what you'll notice is that is actually the case. The intercept actually, it doesn't look like it's shown here because I think this is the weight of 1, but if you showed a weight of 0, what you would notice is that this red line will be hitting the miles per gallon of 37 right here, and then the weight is -5. So what you'll notice is that every time you increase the weight, your miles per gallon will go down by 5. So this actually slope of the line is -5. So now we can actually move on. So we just actually covered the 1A and 1B. Now we can move on to 1E. What we want to do now is actually extract the residuals from our regressions. So as before, we are just saving this regression output. I didn't actually have to run this line of code again because we already have it right here, but let's just do it. And we can actually easily access the residuals by just putting the $sign and then typing residuals, which is actually one part of that saved data that we have. If you actually click on this saved reg output, if you click right here, you'll see actually the various data that you can access with that $sign that we've been doing. So I want to access the residuals, but we can also access coefficients, effects, fitted values, and so on and so forth. And so we can access that actually just by typing in reg output, $sign, and then residuals. And so when I type that in below, what you'll see is that we get a bunch of data. I just use this added function here to show only the first 3 rows, just to make it a little bit more clear. And so that will give you the residual for each observation. That's why you're seeing these car names above. And so what I want to do is actually save those residuals. And so I just do that same line of code here and then equals to whatever it is that I want to name the residuals. I'm just going to call it residuals. I run that line of code. You'll notice that now we have this long list of numbers. And now we can actually plot those residuals. And so we will be using the plot function using empty cars weight. And then the y will actually be the residuals. We use weight here because that is our regressor. If you look in our reg output, the weight is the regressor, right? So if we were using some other data as the regressor, we would actually want to put that other data in the X, okay? just to be clear. And then the y will be our residuals. That's how we generally look at it. And so you'll notice here that this is the scatter plot. And by the looks of it, it doesn't actually look that like the residuals are actually correlated to the weight. So that's actually a pretty good thing for our regression. It makes our conclusions a little bit more stronger. Next, we will move on to problem 1F, and I will actually be using that data frame that is used in the assignment. So this will actually more or less give you the answer, but you're going to have to do a little bit more work and fill in some of the blanks. The first step to this problem is to create a log of income. I'm just going to create it using the same mutate function that we used earlier. So before I save it, I just want to show you what it does. So the df pipe operator mutate, and then I'm going to create this new variable called the exact name for our household income per capita, and then underscore log equals to the log function and that existing data that we have, household income per capita right here, right? And so if I run that, what you'll notice is that there's another column that's been created. That's household income log, but we need to set it equals to our data frame name in order to overwrite that data frame and to put that new data in there. So let's run all that again, and what you'll notice is that we now have a new column. So now we can actually get to graphing. 3.1, this shows how to first create a side-by-side plot. So we're going to run that first. And then we actually have to run a regression for this question as well. And so what we're going to be doing is regressing household income per capita, the log of that, on the percentage of spending on food. And these are both column names in our data set, and they actually happen to be both the columns that we created using dplyr and mutate. And we just want to specify that these variables are from the df dataset. And I also want you to be pretty careful. I forgot to mention that this is not a straight dash. It's the squiggly dash. So just be careful about that. And when we run this line of code, you'll see now that we have this reg log output. And if you want to take a summary of that, as we showed earlier, so summary reg log, you'll see the output, the intercepts, the coefficients, the r-squared, whatnot. And so what we want to do next, after we have that data saved, is first we're going to actually plot, actually not anything to do with the regression. We're going to first just plot these two variables in our regression. We're not going to regress them, we're just going to plot them. So the x-axis will be our household income log, the y-axis will be the percentage spent on food, and then please just fill in these yourself. And so what you'll notice is that we now have one graph there, and we can add the regression line by typing in reg log. Now we will add the second plot, and in order to do that, we first want to actually get the residuals of that regression that we did up here. So we are taking the reg log, same name as here, and then doing the $ in order to get the residuals, and then I'm just going to save that as reg log resids, so you'll see that that data now exists here. And then you will want to plot on the x-axis the log of the household income. It's actually the same x-axis that we plotted in this first plot here. But now we will be plotting the residuals of the regression rather than rather than the percentage spent on food. And this is just a line, like a straight flat line to add. So when we do this, you'll notice that that second plot is now added and the residual data is here. And I want you again to like fill in the X label, Y label. You're gonna have to take a look at this problem yourself. It's hard to explain the entire problem. I just wanted to show you the necessary functions. So please come to my office hours if you want to know a little bit more about the intuition of it. But that sums up 1F, I believe, which is a pretty tricky problem. So be careful with that one. So now we will go on to some other regressions. We are going to import this other data set called the quartet.csv data set, and I'm just going to be saving it as this df_quart and using the read CSV function as we usually do. So run these 2 lines of code and you'll notice that this is our data set. You can confirm that it's been imported by looking up there. And now we will just try to do 2A really quickly here. It's pretty straightforward. You're just going to run 4 regressions. These regressions are using the LM function. And then actually, I'm also just adding on the summary function as well. So we were using the summary function before by just typing in summary and then the name of that saved LM, that regression, I should say, which is done using the LM function. So all I'm doing is just simultaneously using both. So it's summary and then LM and then your data in the middle, right? Sorry, I'm typing down here. I should type that up here. So just to make this clear, what I'm doing here is summary function, the LM function, and then this is the Y data, X data, and then the data, and then the data name, right? We were doing it before by just saving this first in step 1, and then taking the summary of whatever we called that saved data in step 2. So saved data, and then we were putting that in there, right? But rather than doing this, just to save some space, I'm just doing it all in one line and then saving all of these different regressions. So this is actually the answer to 2A. So I run this all at once, and what you'll see is that there's now reg 1, reg 2, reg 3, reg 4. You might notice that it's all blue, but again, you just have to confirm that whatever data that you tried to save actually saved. It looks like it worked. And so if you wanted to like inspect what that did, you can just do reg 1, type in reg 1, which is that saved data, and what you'll notice is that it outputs a regression right there. So if you want to see reg 2, you can type in reg 2 and so on and so forth. I'll show you, I mean, you can just look at these outputs and then write down the answer yourself. But if you want to know how to extract the coefficients and the R squared separately, I'll show you how to do that right now. So what I just showed you above here was just when you show the entire output, but there's a way to extract certain elements from this to make it a little bit less confusing, but you can answer the question by just looking at these outputs, to be clear, and just reading the reading the regression outputs and then writing your answer. But I just want to show you that as before, when we were accessing the residuals, you can also access the coefficients. So reg 1 coefficients, these are the coefficients. So this is the intercept and the x1. So that's the exact same data that you'll see here, but it's just a lot less information. So it's just showing you these lines basically. And if we just want to extract like the coefficient numbers, all we have to do is, if we want to get rid of the standard error, t value and PR and all that, all we have to do is just type this in. This means that you are taking all of the rows and just that estimate column. So if you wanted to take the standard error column, you could just type in the standard error. But we want the estimates, right? And if you run that, then you'll see that this information is a little bit easier to read. The same thing can be done for the R squared. So I think you're probably noticing a theme that you can just access all of that separate information by putting this $sign followed by whatever it is that you want to see. And then if you type that, then that will be the R squared. So again, this here in 4.122 and 4.123 is not necessary to complete the problem, but I just wanted to show you that you can access parts of the data of the regression output, which is a lot. All right, so now we will go on to plotting 4 separate graphs. So this is for problem 2b. This is just an example using the mtcars data set that I'm using. This time, in order to have a 2x2 graph, this is the code that you will need here. So we'll run that, and then using the plot function, we will just plot 4 different plots, as you can see, and then that will show 4 different plots with regression lines. And this is corresponding to 2b. And then we are just getting to the end here now. The last part is doing multiple regressions rather than single regressions. I mean, everything that we were covering before, as you can see, it was just one regressor on whatever it is that we're trying to see how it affects. So this is the y and this is the x, but this is just only one x. All the examples that I were giving you up here, again, just one regressor. But in this final example, we're going to add more regressors. And we are going to be using, yet again, a different data set. And this data set is the safrica.csv data set. So I'm naming it df_safrica. Running these 2 lines of code. Looks like it worked, because you see it output the first couple rows if you wanted to check the whole data set. It's actually quite big. It's almost 20,000 rows. So it's quite a big data set. We can inspect it here, but we'll go back and I will show you how to run multiple regression. So our y variable here, which is the wage, will still just be created by typing wage and then this same symbol afterwards. But this time when we want to add more regressors, we, instead of doing that same symbol, we just add a plus. So I, in this example, am showing this union column and this education column. And we need to, again, specify that the data is coming from df_safrica. And sorry, I forgot to mention, the lm function is still used. So the function is still lm, even for multiple regression. There's no difference. And so I will save it as this reg multiple. Again, you don't have to save it. You could just run it if you wanted. But I want to save it first. And then I want to put the summary function around it. And then it will show us the output. So what you'll notice is that what it added was just one more row here, right? It added this education. And then, oops, this union is also there. And so as we add more, you'll just get more rows and more regressors. So we can do age, we can do experience. Run this. Again, adding another one. Experience. And yeah, that's essentially how you do regression in R. We covered a lot today. If you have questions, please come to the office hours, email me. I will try to do a follow-up video next week in which we will go over the intuition of what it is that we just did. I had to try to race through to show you all the functions necessary to complete this problem set, but next week I will hopefully try to go a little bit slower and explain in depth a little bit what it all means, if you are not able to cover that in the other TA session or the class.